Okay, thanks. Yeah, I am Dawid. I come from, actually, I don't know where I came from. Like, originally from originally from Krakow. I came yesterday from Kyev. By the way, who's from Kyev? Anyone from Kyev? Cool. Did you use train? Yeah, that was like one of the first experiences here. 14 hours train to Bukovel. It's like they said it will be fun, and it was, definitely it was. Yeah, so I traveled by train, and I discovered one more thing. It's like business model of the national train. So you can buy first and second class, and the difference is that you pay twice more, but instead, 3 places in a row, you have the middle place empty. So that's how to earn money in a smart way. As imagine, you have 6 places, so 6 tickets, or you can double your price and sell 4 tickets, so you have 8 tickets. Cool. Let's build businesses like that. Okay. Nope. Nope. Cool. Yeah, so for me, it's like the second time in Lviv. I was 2 years ago on a bachelor's party. They said it was nice. And that's why I came for a second time. Thanks for invitation. And I hope to see more than last one. So yeah, I'm originally from Krakow. It's here. I live in Kyiv now, 8 months. And that's pretty cool because since 8 months, I heard not even a single word in Polish in Kyiv. And yesterday when we came, like we just left the restaurant, there was kurwa mać. So yeah, I feel like at home here. Yeah, I work at Petcube. It's like one of those devices. It's not company promotion. It's more to like inspire you that hardware testing is really cool, or even hardware prototyping. So I discussed with you just 5 minutes ago that you do it for fun, and it's fun, I hope. So I will show it later. And apart from that, we set up Ukrainka meetup. Unfortunately, it's in Kyiv. Fortunately, or unfortunately, it's in English as well. So it's pretty tough to encourage people to speak in English, but it works somehow. So I hope to, like Marta said, it was general stream. So I don't know how many of you were there. It's like switching between general and technical. So it's cool. So many of you are here. And she said, like, it's not so easy to encourage people to speak English, but it's a great opportunity. And indeed, it's a great opportunity. So let's start. Click. No click. Click. I must be closer. So just a few words about reverse engineering. Do you use reverse engineering in your activities? Like, you can imagine what is it. Like, you try to get output and then prepare something based on that. So this is Cyrillic version of my first and the second name. And it's like Ukrainian government. And when they translate it again to Latin name, it's like Dawid Pacia instead of Dawid Pacia. It's cool unless you want to withdraw money because your passport and credit card are not the same. Yeah, let's start. So embedded world, IoT world, who works with hardware, embedded, IoT, or something similar? Just one person, 2. And like hobby or, okay. So some of you know how it works, how it looks like. It looks like here. So quite a lot of mess. There is a solution, you can clean it, but it's a stupid solution. It can work for 1 week. And but that was 4 years ago, so probably maybe I was not so experienced in embedded because it was my first embedded company. So maybe I did something wrong, maybe I needed more items than necessarily, but nope. It's from last week, nothing changed except for company. Still a lot of wires, still a lot of devices, and actually, believe me, it makes sense. All of the devices make sense. The only problem is there is no place for coffee cup, but you just need to gain experience to put it somewhere. Yeah, so I mentioned in the title of presentation, it will be about the risks and challenges. And risk and challenges sounds quite easy. so some points and so on. On the previous pictures you saw it can be not so easy because of all those items on the board, but start. Let's start. So why actually this presentation was created? In 2025, as I remember, Gartner predicted that there will be 25 billion of IoT devices on the market. But when you have real devices, hardware devices, there is backend part, there is storage, there are mobile application or any other front end, and you need to maintain, you need to develop all of them. So you have a lot of things to test. So no worries, they will be still job for you, even more maybe than now, and maybe even more funny. So that's the history of this presentation. Maybe now it's not so popular, but I believe very soon, maybe 10 years, it will be, and much more companies. Even in Ukraine, you have quite a lot of startups, like Petcube, for example. So you may know Petcube, like as a company, because it was like one of the first startups here. And that's why I joined, because it's really exciting technology and really exciting product. Okay, risks and challenges. I have 7 challenges and risks for you. So let's go through all of them. The first one, we live in DevOps world, but actually Piotrek will say later about DevOps. You can stay, it will be a cool presentation. Yeah, I didn't say that. Yeah, so DevOps for me, but is kind of mindset. It's not the position, it's not role, but it's like the different story. So we can discuss it later. I like to discuss what is DevOps really. But because of DevOps, we want to deliver everything in a continuous way. Continuous integration, continuous delivery, continuous testing, continuous whatever. So actually in hardware environment, there's a big risk because you store all the results automatically. So you test something, you have your setup, you get the results. And now you have very common problem. False positives and false negatives. Who knows what is it? Like ISTQB. Come on. Who passed ISTQB? We need to talk later. So false positives and false negatives, in general, if you have bad result, if you have a false result and it should be true, or it's true when it should be false. So I can visualize it in that way. You have false positive, you have false negative. It's pretty uncomfortable in environment implementation, but it's not that bad because you always have the same result. So it can be true or false, it can be bad, true or false, but it's always the same. But then you have something like flaky tests. Who knows what is it? What are flaky tests? Like,
sometimes it's passed, sometimes.
Exactly. So you draw a dice and this time it passed, or this time it failed. So in software companies, in big software companies, they somehow deal with that, like Google, for example. They introduce test cases only if it passed 10 times in the same way. So they avoid flakiness. The problem with hardware-related products is that you have not just implementation issues, but you have also hardware issues or electric issues, and so on. You have wires, you have current, you have voltage, amperes, and so on. So I split it into 2 categories of flakiness. The first one, which we cannot really influence. If you can, then you are like great candidates to be a god. So if you can change day and night, it's pretty cool. I want to talk with you later. If you can change temperature or humidity in the air or destroy walls, the same story. So you cannot influence. If you have wireless communication, you have wall on the way. So depending on how thick is the wall, what is the material, so probably the signal strength will decrease. Maybe a lot, maybe not. even if you have mobile phone and you have Bluetooth communication and you have some obstacles, still, you don't know. So it's hard to control, and it's nice to be aware of that in IoT, flakiness is not something that we can fully avoid, but if we can understand that there is flakiness, then it's much better. You can investigate, you can find the issue much easier. The second one are all those connected with your implementation. So it's not intentional mistake, but it can happen. And if you build some on the R&D phase, some environment, and you connect wires in a not very good way, or you have electricity peaks, like, I don't know, I discovered in Ukraine it happens more often than in Poland. So that's very good, like, for your self-development. Then you think how to protect your environment to not be very influenced by that. Memory leaks or many other, just pointed out some of them. So something that you introduced, but you are not aware of that. So it's good to know as well. So we have two reasons. One is environmental, and the second is because of your implementation. The second point, and for me it's the most important. So who of you think about updates? Who of you test updates? Okay, not a lot. And thanks, Fyodorek. The first one is web. So you can be like Amazon, like Google, and deploy every 2 seconds or every like 5 seconds. But I suppose you are not. I believe you are like on the same level, but probably not every 2 seconds. So if something is bad, you can make a rollback very quick and then restore previous version. Restore database, restore whatever you want. And it's pretty quick, it's pretty fast. So that's how the updates look like in web. Then you have mobile applications. And then you need to push it to store. In iOS, as I know, they review application before it's pushed. Yep, it's OK. So it's like not so comfortable. You cannot do it in 5 minutes, in 10 minutes. You need to introduce change and then waiting for review. But still, it's like maybe 1, maybe 2 days, and it's done. You can say to your customer, hey, we have fixed. So you can update this application, and it will work again. Then we have desktop applications. Anyone working with desktop? OK, not, but it's quite passé. But it's great fun. So in desktop, the problem is you need to encourage customer to update. He or she need to mostly download it and then update. So it takes time. And sometimes maybe remove and install from the beginning, losing all data. But still, it's not that bad. You can do it remotely. So what happens when you have IoT devices? Remember, it's hardware, very often wireless connection. And if something went wrong and your device is bricked, by bricked, I mean it doesn't work at all, because software that you put there destroys something, and it just cannot reboot again. What is the solution here? Call to your customer and say him, hey, could you kindly resend this item to us, and then send it again. I believe it's not the good solution. The only way how it will work is, OK, I was your customer 5 minutes ago, but I'm not anymore. So there's a huge risk. And just imagine you have new updates, and you want to update 100,000 devices. And usually it's how it happens. You push new update to all the customers. If there is breach, if there is any break, any memory leak, there is a problem. I mean, problem with those hundreds of thousands devices. So it's good to somehow deal with that. And there are some solutions. So I called it safety belt, how to avoid, how to maybe mitigate the risk of introducing such issues on the customer side. And firstly, it's definitely continuous upgrade and downgrade. So checking compatibility between versions. Like, it's good that at least some of you check compatibilities and updates, in IoT world, it's good to know that it's must-have, even in the early stage of test automation environment implementation. Because you push something to the customer, and customer already have that version. So it's good to start it from the beginning. The second one is to split it into small batches, and it works pretty similar in mobile applications. So you can choose 1% of your customers to update at the beginning, then 2, 5, 10, 20, 50, and 100. Exactly the same here. So just split it into small batches, then gather some statistics, and if everything is good, then push more and more. The same way it works with mobile. And the third one is something I called backdoor solution. So all the other solutions we can have. Just let me say more about it. About continuous upgrade and downgrade, it's good to have internal laboratory. For mobile phones, you have, it's called farm, as I remember. A lot of real devices and so on. For hardware devices, you can make the same. That's just more fun because it do something like lights and trees and lasers and something. So magic. And put it into CI environment. So do it in the continuous way. For small batches, yeah, there's one solution to choose a percentage of customers and push them all those updates. But you can also have beta and alpha customers, which is, I think, more and more popular solution now, and just send them, or something called early adopters. So have you ever heard about early adopters description? Yeah. So that's a really nice solution to find that kind of people. And backdoor solution, well, you have infinite number of ways to solve it, probably. What I just found out when preparing, it can be wired connection. So when wireless connection doesn't work, you can just connect it in a semi-manual way. It can be storing somewhere backup, but again, here is a risk of losing money. Because when you store it somewhere, you should put it into cloud. But when you put it into cloud, you pay for the storage you have. So that's the solution. If it's good from the business perspective, I don't know. Anyway, maybe it is. And several partitions is a very technical one, but you just split your memory into several parts, and when one is updated, you can store into another. OK, we have 2 risks done. Then scale. As I said, hundreds of thousands devices, 25 billions of devices in 2025. And who of you test performance? Who of you test scalability of your devices, of your environment? OK. Thanks, Piotr. He's a good tester. So previously at my company, I had a laboratory of 200 devices. Why it's good? Well, for 5 devices, it worked perfectly. Then customer came and he said, hey, I have like lightning. I want to have a lightning environment in my wall, but I have 30 slots. Show me how it works. And 30 devices didn't work at all. I mean, maybe even better than didn't work, because some of them turned on, some of them turned off. It was more disco than presentation for the customer. And that's why it's good to test scalability. Now it's not about lightning, it's more about those cameras, but still you have common parameters you can check. And firstly, it's number of devices, sure. So you have requirements from the business, how many devices should work at the same time. The problem is thinking for the future. So maybe you will want to extend your requirements, but your current hardware won't support it. So it's good to think in advance. And any like geographical issues. In US, we have 110 volts. It's a different frequency. So when you connect devices, it's hardware. maybe it will behave in a different way. That's the first problem. The second one, everyone, like in Ukraine, use Apples. So I don't know if that's true. Who don't have Apple phone? OK, in Kyiv, it looks a little bit different. On a subway, when you count people leaving the train, the metro, you maybe found like 1, 2, 3 records among 300. So a lot of people use, in US probably 90%. And it's connected with, so you have mobile devices based on, which are like iPhones, but you have also, it's airport, as I remember, router. And it's totally different with settings than we have. So there are a lot of differences we do not even think. So it's good to think about it. So scale really matters here. The fourth risk, real user behavior. So I entered in Google random IoT devices. That's the first picture I found. Sonos is the wireless speaker. Does anyone know what is this product? It's pretty popular. So what you can do, you can control it using any front-end interface. But for those people who don't like phones, you can play it here. So turn on, turn off, decrease or increase value. Now the question is how to test it. You have real buttons, and you want to put it into environment. Even if you want to test just component, which is hardware, without an integration with backend, without mobile application, well, you need to somehow check it. And here comes another embedded platform. So you can build your own platform. For example, Raspberry Pi, I think, is the most fancy now. And you can connect it as part of continuous integration part. The only advantage is that you can set outputs on general, it's called general input output GPIO. Exactly, interface, something. So you can set signals. What you can get by that? Well, when you set 1, this guy will be turned on. When you set 0, it will be turned off. So you can control it in a very easy way. And then just way of thinking how to implement this is what the user really can do here. So buttons, play, changing volume. Then it can connect or disconnect to Wi-Fi. And the same story. You can just disconnect router and connect it again. So there is like nice corner case when the device is connected to router and the router has no access to internet. A lot of devices have problem with dealing with that problems. So for example, it cannot restore connection to internet later because it was connected still, but it just didn't have connection to internet. So to summarize, the solution here is to firstly identify what the user can do, like he can see and touch device, and the second thing, to implement it in a way that customer can do it. Yeah, for example. Fifth risk, and that's my favorite, because now it's not popular. Can someone say what is CXA? Probably not, no one. Yes, it's not formal description. So it's done by me. But maybe in case someone knows. It's customer experience assurance, and nice name, yeah? Thank you, thank you. I'm on a way of writing books, so no worries. What is customer experience assurance? Any ideas what can it be? Kind of user experience. No, it's not only about hardware, but customer experience assurance is when your functionality is working, but not in a way. Actually, it works exactly like the requirements say, but it's not working from the customer perspective how I expected. So for example, okay, I need to turn it that way. You have this LED bulb. Now, it's turning white. what do you expect when it turns when it's white?
Powered on.
Exactly. So when it would be red, then what? Something's wrong. That's common explanation by developers. Something's wrong. Yeah. So it can be rebooting, or it can be disconnected from Wi-Fi, or it can be just not working. And when it's green, for example, it can be like I'm waiting for setup. And that's this example about. So the customer, I have heavy fingers. The customer expects that it behaves in a way how I feel it, how I see it. So I want to have that behavior how I feel it for another device. I have LED notification. When it's working, I want it to be red. I want it to be white or green or maybe blue or any other colors, which will be understandable for me. To understand it better, we have laser for that camera. So my cat likes to follow that laser, but when it behaves in a laggy way, so once you have here, then here, here, and here, the functionality is working. Any automation test will pass because it's working. I can see laser. I can see moving laser. But for the customer, it will be quite uncomfortable to see how his or his cat is like crying or feeling pain of still disappearing laser. And it's hard to test it in automatic way, even I would say pretty impossible. But it's good to be aware of that for the customer in IoT, very often more important than requirements, than working functionalities, are functionalities working in the way I really expect that. And one more example, it was officially reviewed, so I can say about it. It's not really nice. So this is cat. Who can describe face of this cat? It's shocked. It's even more. It's scared. And so what was the problem? And again, for me, everything worked really fine. For that guy and that cat, the problem was that all those suites, all those treats were launched too fast. And the cat was running away. Like when he saw this device for the second and third time and heard when it's rotating, he was somewhere under the bed or in the wardrobe. And again, I can say functionality is working. It's working following the functionalities. I can even check it in my automation environment. But I wouldn't expect like this cat will be scared of too fast treats. So this is what I mean here. It's very tough to test. It's very not intuitive. Unfortunately, the more IoT devices we have, the more such problems we'll have. And it's not easy to fix later, because how can you refactor hardware when it's already on the production? You can just mention that only for brave cats, but it's not what customer expect. How we can mitigate it? So we have risk. We have big risk. What can we do? So definitely, close cooperation with support team is pretty welcomed here. Who of you cooperate with support team? It's pretty nice. You can get very quick feedback and feedback about things that you didn't notice. And for you, everything is fine. For customer, it's not. And usually, support team is treated as like separate team, far, far away. Like Marta said about testers in Costa Rica. We have support in Philippines. And it's not because they are cheap. I mean, maybe that's one of the reasons. But it's the same time zone as in US. So that's why. But because of that, the very problematic for us is to cooperate. And that's the reason why people very often do not want to closely cooperate, because you have maybe 2 or 3 hours per day to talk to them, but you are by the end of the day, you don't care, they are just coming and probably drinking coffee, so you are mismatching somehow. But in that way, in that case, it can be very valuable. Then it's exactly what I mentioned already. So beta program, beta testers internally. Actually, yeah, by internally, I mean not fully internally inside the company, but like your families or friends and so on. So that's what I call internal. Internal because you can quickly receive information from that person. And of course, it should be also alpha testers. Then crowd testing or crowdsourcing. Who knows what is it? Yeah. Crowd testing or crowdsourcing. Yeah. For example, so that's kind of platform for testing. And from my perspective as a customer of that platform, I can employ 20 Chinese guys to test this device. And what is the value here? You can choose different time zones, different locations, different, I don't know, ethnic, and so on, different customers, different gender, and get more feedback because you cannot scale all those requirements in your internal lab. So you can test it in the real life environment by someone else. Then prototypes is more about electric. It's not for testers usually, but it's good to know as well that on an early stage of prototyping, maybe there is someone who should test it. Even if it's not you, just to build that kind of culture inside the company to let people understand that building quality should start from the requirements. And in case of hardware, is even earlier. It starts with building prototypes. And the last one, Amazon. I mean, not only Amazon, but any store you can aggregate results. And how did we use Amazon as a source of feedback? So this is the chart of all rates from the customer. So it's not so tough to write kind of wrapper to pull all the comments and then by keywords finding what was the problem. So maybe laser, or maybe connectivity, or maybe something else that for us is working fine because we test in place here in Ukraine. And all those charts can firstly find the risk, in project and product risk that you have, and secondly, prioritize the further effect, the further activities. So definitely here that one and that one is the problem because a lot of one-star ratings. And for hardware products, Amazon is, if it's US, Amazon is like the most important, definitely the most important. Because when you buy something, probably you look at rate. If rate is low, you buy something from your opponent. I don't know if that's the correct word. Okay, so fifth risk was about CXA. Does anyone remember what was that? Cool, cool, you listen. The sixth is high voltage. In Ukraine is 220, 2000 is probably somewhere, yeah. But, oh, anyway, can anyone explain one is 220? Like, not 30? No, no one? No one working in electric? I don't know. Okay, that's unknown question. Let's leave it. Oh, that can be the answer. So in US it's 110. Actually, it doesn't matter what is the voltage. What matters, it's high voltage. So it can break something. It can destroy something. And to let you understand, here is the story. 30 seconds to read the story. Who's the hero on that picture? No? The gold one. It's isolator, so it's something that protects you. Can I somehow touch it without? Okay. the gold one that isolate high voltage, and then you won't destroy it. And when you work with high voltage like lightning is here, in the worst case, you can lose the whole environment. I mean, it's definitely the worst case. It's money, it's environment that you need to restore. Yeah, that's why. So, and then the last thing is great disappointment from your boss. That what's going on? What's going on? Why it doesn't work? Because it's like broken. Yeah, so that's like to let you know. And why did I put it? Because we made a lot of mistakes based on that. I don't want to count even devices we burned, but it's a lot, quite a lot. I know there will be a question about the price of that mistake, but let's do it later. Yeah, so that's pretty low risk if you know about it. If you don't know, now you know. And the seventh, it's open source. As we know, it's open source, it's free, so we cannot trust it in 100%. And the example here, yeah, it's kind of environment. It's pretty bad because it's done by testers, not by guys who learn with electronics. But yeah, relays. Then we have switch to control. So it's that kind of real behavior of devices. It was previous company, so we turned on button, and then all the bulbs could turn on. And here was one problem. So here is like external wire, and here is connection with debugger. Debugger is something that you can push new software to the device. So there was connection between Raspberry Pi and this debugger. It was pretty nice. And sometimes we just need to reboot debugger. It's like you can reboot any device. But in open source, it didn't work. And our assumption was, hey, it must work. It's like it's done by Texas Instruments. How they can do it bad? And they did. And when we sent them requests to fix it, they said like, we don't care. It's open source, and it's not our product. We won't earn money for that. So what we did is like to build kind of workaround. It's ugly, but it works. What is the issue here? Just to do not trust fully when it's hardware in software in open source. But probably for software, it works exactly the same. We have 7 risks. I will summarize it later. Anyway, if you protect all, I mean, you try to mitigate, you protect all those risks, shit just can happen. And I have 2 examples. The first one is Airbnb. Probably most of you know what is it. It's like, someone do not know what is Airbnb? Yeah, you can find a place to rent a flat. And some company did like pretty nice thing. So they created smart lockers. So what you need to have is just mobile application, and then you can, using, as I remember, NFC, just push your phone, and then you have doors open. You do not need to even talk to this owner. What was the problem? There was a problem with updates. So all locks just bricked. And the guys who booked the holidays, they couldn't enter the flat. It's pretty bad start of your holiday. It's even worse when you are already on a holiday and you just went to see the city without any stuff, just with your shorts and t-shirt, and it's night. And the problem was just with updates. So something that we do not really care for IoT, yeah, definitely it matters. And that's like great proof. The second example is with pet world. And here is like the dog, and it's feeding machine. So you can feed your dog or cat. And if you want to keep your dog or cat in a but you want to just keep them fit, yeah? You have a hipster cat, and he must be like strong and very flexible and agile, whatever. But then you have this device that split portions to feed these animals. So for example, I know 100 grams at 12, and then 200 grams at 2, and so on. The problem was with backend. Backend just stopped responding, and that was quite a big problem. And I love the solution from CEO of the company. CEO just recommended on Twitter, do not forget to feed your pets manually. So definitely, IoT is very risky. The risk is much higher than in software. Maybe only medical devices are like more influenced by risk, but actually, medical devices are IoT as well. So just to be aware. Okay, fun time. Firstly, it's never just hardware. So whatever you do, if you have department testing just hardware, there is a lot of other parts. So you have kind of front end. In that case, it's mobile application. And you have kind of back end. It can be storage. You can use Amazon. You can use microservices. So everything you probably well know. And it's never just hardware. Just never. But yeah, hardware is the most risky part. Then practical usage at home, and that's what we discussed just before presentation. You can make a lot of really nice things. And what I found is, like, because it was the only pet solution I found, it was the guy who built face recognition for cats, because it was semi-wild cat, you know, running to catch mouses. And then, when it was the time, he got back and wanted to enter home. And you know, knocking didn't work because owner was sleeping. And what? Food at home, mouses outside, but it's night, so no mouses. I'm starving. So the guy solved it in that way. It's embedded platform. I think it's Raspberry Pi Zero, so something even cheaper than the normal one. And just implemented vision system. And here is cat, not smiling cat. Probably is the first entrance after implementation. And this was pretty nice. So this system could recognize just this cat. If that was not that cat, it didn't open. So it's a smart solution. And it's extremely easy. So it took probably half a day to implement. And another smart solution is to integrate all those hardware items with services. Like everyone uses Slack, yeah? And this guy did the same, and then when the cat was found on a camera, it was just sent on a Slack, open the door. Man, human. Yeah, so it's pretty easy solution. It's quite quick to implement, and it's fun. It's definitely fun. Now, work with awesome technologies. IoT is pretty new. So there are new technologies to integrate. We have smart home. It's quite popular on the market. You have beacons. Beacons are IoT devices that just send signal. So for example, when you are at the gallery, it's like the newest solution, you have phone. So when you come close to the to one of items, you can see the description. It's passive element, just sending signals, and it's very, very cheap. Another solution is it's Bluetooth. It's new Bluetooth 5.0, and for example, Alexa, and it's US device. Do you know what is Amazon Alexa? Okay, in Poland, most people do not know, probably because it's US. So you can talk to this machine, and it's pretty cool. You can integrate with whatever you want. You can be somewhere outside and say to, hey, Alexa, feed my cat. And then the cat is fed. But still, there is a risk. So I remember a story, it was on Guardian, probably. There was a parrot. So the story sounds like Hitchcock one. There was a parrot, and the guy was ordering very often some food. So this parrot did the same, just 200 times, when he was outside. So that's another risk of IoT products. Okay, and exciting real test cases. So that's why I bring this here. And just let me make a quick demo. For example, what is exciting? One of the most popular features now, and it's not just for this device, is to recognize the natural behavior of your not only animals, but also humans, for example, at the airport. In that case, it can be when the dog is close, the dog is calling you, and you can answer and say, hey, yo, man. And then just talk to that guy and feed them, feed him or her, because it's your pet. And, oh, actually, I have the question. This is my Christmas cat. She's called Luna. Do you know from which series the name Luna comes from? You will receive this chashka. Yeah, so yeah, it's from Sailor Moons. Did you watch? Yeah, it's like the childhood porn for. Okay, yeah. Just let me show one example. So we have the main feature, launching treats, and now I need to switch for a moment. I don't know if I can write and talk at the same moment. Let's start from the bottom. So I said we have firmware. Firmware is software on the hardware devices. Definitely, like when you follow the test pyramid, is the lowest level. Yeah, it's kind of function only for this component. I'm skipping unit tests because writing unit tests for firmware, it's for me it's magic, like Mr. Bean said. So I start with component, and here is just wired connection, and it's does anyone use Python to implement tests? Yeah, so there is a library, it's called socket, and it supports TCP, SSH connections, and so on. So exactly that's how it works. Just give me 20 seconds. I have something to launch. It's like advertisement. I should smile, yeah? Okay, you are a brave guy, yeah? So we trust you. Okay, so as you can see, even here, it's written in a very low level. Whoa. Yeah, so that's fixed for that cat that was scared. Okay, so that's the lowest level, and definitely you should start with that. Let me stop. I forgot it will do that 10 times. Okay, I stopped it. That's the lowest level. Implementation of that is quite tough. It's even painful because of stability. But when you write it, when you have maintenance of all the sockets, then writing tests is extremely simple. So you just send the comment using API on the device side, and that's all. So when the infrastructure at the low level is done, then can you hear me, by the way? I just forgot. When you implement it on a low level, like infrastructure, then implementing test cases is pretty fast. And probably it's up to 1 week to implement all functionalities, if it's like done, if you have documentation. Who has documentation? Okay, so that's the lowest level. Now, the second one is integration. And as I presented before, where is it? There is kind of backend, and backend probably supporting RESTful API communication from both sides, from device side and, not that one, from device side and from customer side. So mobile application backend, and then backend device. And this is like device backend part, sending just requests API. And you see it's written in BDD way. It's not, Yeah, it works. It's not so tough to. It's 99. Yeah, so it's integration part. So you can use that guy and usually kind of backend in any way. Here is like REST API communication, but whatever. And I presented before very rough kind of testing. It was just script. Here we have BDD. And it's like to differentiate, to show that you can use it in any way you want. You can use BDD approach. You can use unit test approach. For example, in Python, they use unit test library. Or you can just run separate scripts. And I don't want to say that BDD is good and running scripts is bad, because if you have well-structured functionalities, you can just split files and then run them. So everything depends on the context. And the last one is like the end-to-end testing using mobile application. Just give me a moment, because I use Android 4.2. Whoa. Whoa, man. Yeah, I have, but it is just broken. Like I have 8.1, and for 8.1 it works perfectly. For 4.2, not that good, but I hope it will work anyway. So we have mobile part, and here is the third way of implementation. It's written in unit test way. So you have setup, tear down, and then the proper test. If anyone used it ever in Python, it's pretty well known. Always, yeah, setup, tear down, and launch test. So let's run it. No. Okay. So it can be slow, because my equipment is quite old-fashioned. Cool, it's connected. There will be advertisement in 10 seconds. No worries. Yeah, so it's quite a long process because of because of old device. And what I can say during the test execution is that definitely the first one, as you could notice, is the fastest one. And this is how test pyramid is working. And the top and the bottom level is the fastest to execute and the most stable. Then you have integration part, and you have end-to-end part. It's good to use kind of end-to-end test, but what I really recommend is to use it in a health check way to just validate if your system is working properly. Because if you want to cover all functionalities and you have IoT devices, it can be kind of very long process. Like here, something is bad. Oh, I know, advertisement. Yeah, this is end-to-end test. So we have mobile application, very slow. Very slow phone, not mobile application. Mobile application is, of course, very fast. Yeah, so it's pretty slow. Then the second thing is that depends on internet connection, and internet connection here is not that good as well. Yep. So let's wait for a moment until it will fail. Let's try it once again. So just to summarize, when you think about IoT, you have 4 levels of testing, starting with unit test, and I do not recommend to write it because usually it's C or C++ level. It's developer work, especially here. Anyone can write C or C++? 5 minutes, okay. Cool, so I cannot. And then what I recommend is to start from the component test. Probably you can need some support from developers, because to set up communication is quite technical way. But when you already have this structure, then you can just implement following requirements. Then you have integration phase. It's probably the best, the most well-known part. Just REST API request, and then responses, and just parsing it. And then at the end, you have this end-to-end testing, which are slow, which are very sometimes unstable, but still, for me, I think it's good to have at least health check. And here you have like health check didn't pass. Health check, like health in medical devices, and check like check. Okay, I have 5 minutes, so I will get back to it later. Maybe the internet will be better in 2 minutes. I just want to show you one more slide. Loading. It's loading. Czytuję. Yeah, so exciting test cases, definitely. You are still okay? Yeah, you are. I have a shield. And that's what can go wrong. So everything works fine, even too fine here. So it was randomly triggered, and then this guy was somewhere on vacations. And when he got back from vacation, his dog, as I remember, was pretty full of food. So it's opposite problem to that one that guy from feeding pets had. It's totally opposite. So instead of starving, you can send to rehab. Okay, so I'm pretty close to the end. I have one more off top here, why my presentation is about cats and dogs, and that's absolutely not because of I'm working in Petcube. That's not the reason. The reason is because it's growing up very fast. And this application, I forgot the name, but it's like, you can see what is here. You can choose city, you can choose what you want to buy as a service. It's, you can take a short walk, you can buy deluxe long walk, and it's like adding the new dog costs $5. It's like, Uber for pets. So you can order your driver and just let your pet going outside. So what is the problem? Let's say problem here. The problem is that this startup earned $300 million in 1 week from investors. So it's quite funny product, not for Americans. They treat it very serious. It's even more important than taxi service because it's your pet. So that's what I want to show, that even those stupid, funny things for pets, from business perspective, well, it can work. Takeaways, just to summarize quickly and then try to launch again. Flaky tests. Do you still remember what are flaky tests? Cool. 1. 2. Updates. So probably you remember because of those issues with lockers that updates for IoT are pretty crucial. Then scale. Still, remember what is the scale problem? When you want to build a higher infrastructure, the higher environment, and you just didn't check it because you do not expect it can grow up so fast. Then testing real user behavior, for example, switch or something similar that the user can do with device. Then CXA, what is the abbreviation? I love to be here. Then limited trust in open source, especially for hardware and libraries delivered by third-party companies, even if they produce it for their products. And it's hardware, so it's physics, and you like physics, yeah? Physics is a bitter thing, and sour probably sometimes. But yeah, physics unfortunately still exists here. Who likes physics except for Marta? Yeah. Good, that's very good. I don't like. I like maths. And just have fun when you will try, when you will join companies working with IoT, or you just want to make like vision system for your cat or wife. So thanks.